Hello class, and welcome to my video on data types and attributes. This is Michael Rhodes, and I'm here to help explain to you what data types are. Just a brief definition of them. Data type is a classification of data, and these can range from a bunch of different things that I'm going to go over right now. So if you look on the screen right now, what you can see is a tree stemming from data, and underneath this tree you have three different types of data that we're going to go over. I'm quickly going to tell you a little bit about each type of data and then show you examples of each one. This first type on the left right here is the decimals type, which are basically your numbers that you're going to use regularly. And here we have split off into two different types, fixed precision and variable precision. Fixed precision is interesting because it uses an exact memory intensive way to store the data. As you can see on the screen, there is a number of precision digits, which are the digits in front of the decimal point, and there are scale digits, which are digits below the decimal point. This is nice because it can store exact numbers, and it can be useful especially if there's a lot of decimals after the place, but it is also very memory intensive. Now on the screen you can see the variable precision, where it has a limited amount of precision. It has on the very far left a sign which determines whether it's negative or positive, then an exponent bit where you would put in your numbers, and this fraction bit is where you multiply the exponent by a power of 2. This could be anywhere from 2 to the 1 to 2 to the 45th. This lets a lot of space be able to be used, and it's very space efficient. The only problem is that there can be weird rounding errors due to the fact that it's multiples of 2 that are being used. Going back to the chart right here, so that was the fixed precision and the variable precision, but now we can look at the text. And in text there are two major types. There's the character or char version and binary objects. Char is your basic strings of letters and numbers. These need to be processed by SQL in order to find out data, and out of char you have fixed and variable. Fixed sets aside certain places for numbers, so you can have a fixed 10 where only 10 spaces can be used, whereas variable just shortens those spaces to the length of the word. We'll see an example of this later. Binary objects are stuff like text, images, or something we call blob, which is binary large objects. The final one we have is dates and times. Datetime is basically the date and the time of a entry. If you look on the screen right now, you can see a set of datetime. It starts from the left where it goes year, month, day, and then hour, minute, second, millisecond. It's used to basically store dates and times, and it can be separated in different ways, which I'll show you later. So that is basically all right now for the overview. So let's go to some examples that you can actually look at and comprehend. So right now we are in Microsoft Paint, where I have a bunch of numbers and pictures and words up there, and we're going to look at what each one is. So to begin, we're going to talk about binary objects and what those are. Right here you can see a string of binary numbers, the 1011. This can be used in either binary objects or it can be numeral and it can be stored binary. I didn't really cover this, but it's an important fact to realize that if you wanted to store binary, there's a specific set called bit or byte to use on them. Expanding out, we're going to use blue to show those that can be included in the numerical values of the decimals. So that would include 1.2, which could either be fixed or variable depending on what you want. So it could either be 1 in front of the decimal and 1 behind, or the variable would be a power of 2 in there. Also included in the fixed though is money, so money is included in the numeric, as it has usually a fixed decimal place with like 3 or 4 or 5 in the front, and then usually 2 decimals behind that. After that we are going to circle, let's do green for characters. So these are small strings, so this would include all of this together. Because the strings can include numbers, they're technically letters in this case, so all of this could be under the character string. And if we look at Mike, if we looked at it in the fixed variable, what we would see is there would be spaces. So if we did say it was fixed 10, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 after it, and those spaces after it would be empty because they're fixed. If it was variable, it would just end right after the string. So right here, there'd just be 4 spaces for Mike, no extra spaces at the end. And this is more space efficient, but it's tougher to search for words as the way that it searches for fixed, it searches through from every 10. It starts off every 10 and then it looks at every other one. Whereas variable makes it tougher to find as each one is stored in, say, 4, and then the next one could be 7 or 6. But there's probably more in-depth videos that show how that works. Another interesting fact about character is that it also includes foreign numbers and letters usually, especially if you're using Unicode. So when you see nchar or nvarchar, which stands for n variable char, what you see is you can use, that's the N stands for Unicode, and Unicode is a type of character system that uses all sorts of languages. It has almost 2 to the 30th number of characters, which is quite a bit, probably more than you'd ever need. So as you can see right now, I've included a Russian word, and this Russian character right here, which would be included in text. This word means da or yes in Russian, by the way. So then we can go to pink, and this is for the binary objects. And I chose a house. And this is an image can also be a binary object because it basically stores information, but it doesn't have the ability to process it. So technically all of this would be in pink because you could put this in, but it wouldn't really be able to process it without some sort of advanced numbering system. XML is a way to do that, but again, that's another video you can look up. And finally, we're going to look at the date time down here. I'm going to use purple to separate this out. So this whole thing right here is date time. You have the date, 1992, the month, September 6th, or September, and then the date, the 6th. And then you have, this should be split up, 19 hours, which is 7 o'clock, 40 minutes, 30 seconds, and 175 milliseconds. So to split this up, what we can do is chop it up into date, so that draws a line right here. And that only leaves this front part right here as date. And if you did time, it would chop it off, of course, the back part over here. And that's important because the parsing of time is really difficult. So when you write this, you would ignore these semicolons, or at least the program would ignore it, and it would just read the number from left to right. So if you were looking to maybe write the day like 09, 06, 1992, it would mess up that translation and put the year as 906, the month is 19, and the day is 92. So it's important to remember to keep that in order. So that's it for all the major types of data. One cool data type I stumbled upon doing this recording and this video was the hexadecimal literal. This is one that's base 16, and it goes from 0 to 9 and then A through F. And what this is used for is the color chart that we all know and love, in order to find spaces, and that's why it looks like this hexagon, because it's using 6 numbers and letters to create this kind of shape of colors. Really interesting, but maybe not too useful. So in conclusion, all of these data types are very useful in SQL, creating SQL tables and in SQL in general. And they're important to know when doing queries and when just creating tables, or even like looking at SQL tables. But I will cover how to use these and how they're useful in SQL in another video. For now, thank you for watching. If you have any comments or questions, let me know. And thank you for your time.